8.6, the last question of this homework assignment. Question number 15. Yeah. Actually, it is not hard, yeah, but some students, it's very easy to get something wrong here. So I want to really compare these three different types of efficiencies. Which of the following types of efficiency is the best to describe the overall efficiency for an algorithm? Overall. So we want to consider the overall. So the best one that can reflect the overall performance. Yeah. All right. Here. So let's look at all the possible cases. Yeah. All the possible cases for the input data. Yeah. Here we consider input data. Yeah. Yeah. When we have input data, here we consider some, general algorithm. Yeah. Arbitrary. Yeah. Very general. All right. We know for different input data, the efficiency measure for that particular algorithm could be different. For some input data, it runs faster. For some input data, it runs slower. All right. Yeah. So that's the general case. Here, let us describe the input data. I1, input number 1, I2, input number 2, and so on, right? So let us list all the possible input data. Yeah. Because it must be a finite number, right? Yeah. Not infinite. It must be finite number of input cases. Yeah. So the last one we use I capital N. How about that? All right, so now that's all the possible input cases. Among them, there is only one that corresponds to the best case efficiency, right? Only one. Yeah. Yeah. Only one. Is it only one? Yeah. Here, let us just assume, because sometimes it may not be only one, right? Yeah, there is a possibility, you may have more than one input cases that all correspond to the best case. That's possible, yeah. But here, in order to discussion easier, let me use I and minimum. Yeah. Minimum. So this gives us the minimum measure, efficiency measure. That means the best, right? Yeah. The smaller the efficiency measure, the better, right? Yeah. So the minimum. All right. Then the worst case, how about we use max and max? Yeah. This corresponds to worst case efficiency. This corresponds to best case efficiency. Now we want to look at, so which one is the best to represent overall efficiency? Now, think about that. If you use the best case to represent overall, because the best case, this number is smaller than all the other numbers, how can you use one, the smallest efficiency number, you can represent all other efficiency numbers, right? Similarly, for the worst case, the largest efficiency number, right? Yeah, worst case, the largest efficiency. How can you use the largest efficiency number? You can represent all overall, all possible efficiency cases. numbers, right? Yeah. Then here, when we consider average case efficiency, but when you do average case, you take the average of all the possible efficiencies, right? Yeah. So here, it may not be the rigorous formula, but you just get the idea, all right? Yeah, because to make the representation easier, here I just take the average, all right? Total number of input cases, N, capital N. Yeah. Efficiency for each one, right? Efficiency number for each one, yeah. I1 plus I2 plus ... right? Plus I, yeah. So this is the average case efficiency representation. All right. Can we use this to represent overall efficiency? Yeah. Because we factor in all the possible input cases. Yeah. So this one, we factor in all the possible input cases. The best case, only one case, one of the N, capital N cases. Worst case, another one of, only one, still only one of the N possible cases. Yeah. All right, so with this background, now you try to answer this question. Yeah. All right, so let me stop here and we complete the selected questions in this assignment. Yeah. Other unselected, so you need to answer on your own, right? I do not give any explanation. You just solve them by yourselves. Yeah. All right, so let's stop here. Yeah.